So here's two statements. Here are two statements that are geometry specific. Conditional statements again, if then form. In fact, in the first one right here, if two angles are vertical angles, then they are congruent. The part after the if, remember, is the hypothesis. The part after the then is the conclusion. Now, there's other forms that I just want to mention real quick that our curriculum holds you to. And I don't know if you ever heard anybody say, my grandma used to say this, mind your P's and Q's. The P and the Q part of it is another way to talk about conditional statement, where P is the hypothesis. So P just represents some statement and Q is the conclusion. Now, there's notation for this. And notation is always, one of the points of notation is often to make it easier to write. And so if you see something of this form, it's saying if P, then that arrow represents then Q. And in this case, P is two angles are vertical, then they are congruent. Is that true, by the way? And I don't know. We haven't really looked at this too much. This is going to lead to a theorem called the vertical angle theorem, where we look at two vertical angles and we're going to discover that, yes, indeed, those two angles right there, they are going to be congruent. So it is a true statement. I'm just telling you that, and we'll do some work with it to show that that has to be true. There's another way to rewrite conditional statements. And so what you can do is actually see what happens when you switch the hypothesis and the then around. So what would that mean? Well, it would mean if Q, then P has to be true. And in our case, remember, Q is this conclusion. So here's how you would write it. If two angles are congruent, then they are vertical angles. So yeah, we reworded it, but we basically switched the conclusion and the hypothesis around. If two angles are congruent, then they have to be vertical angles. Does that have to be true? What's the truth value of that? Well, here are two angles that are congruent, but those aren't vertical angles. So sometimes when you switch the conclusion and the hypothesis around, you get a statement that is not true. That switching the hypothesis and the conclusion around is called the converse. Converse. And I need you to know the converse. There's 4 different types of manipulating conditional statements that's done as this section. I only need you to know 2. The original conditional statement and the converse. Converse is switching the conclusion, the hypothesis around. Let's look at this next statement. If two angles form a linear pair, then they are supplementary. And this is actually a geometric statement we're getting later on called the linear pair theorem. And I'll talk about what theorems are as we progress through this chapter. Another way to represent these things besides P's and Q's is in a Venn diagram. Now, it seems like a lot of geometry students come in having some experience with Venn diagrams. If you don't have any, it's okay. Venn diagram is basically making circles. And so I'm going to make a big circle. And in this big circle are supplementary angles, all of them. Supplementary angles, and I abbreviated there for supplementary. Inside of that is the hypothesis if this is a true conditional statement. So angles, so linear pair for linear pair angles. Now, if you think of it, linear pair are definitely supplementary, but they are part of a bunch of angles that are supplementary. There are more angles out there that are supplementary that besides linear pair. Okay, so I hope that makes sense. Be able to take a conditional statement, put it in a Venn diagram, and vice versa. I haven't shown you that. So remember, the hypothesis is inside, the conclusion is the outsides. And also the P's and the Q's, being able to take a conditional statement, write in the form of P and Q, and then being able to calculate what the converse is of that. Okay, so go right from a conditional statement to the converse is something else I want to hold you accountable. Thanks.